So as we know in last class, I taught you what is this alpha rays scattering experiment. That is what done by Mr. Rutherford to discovery of nucleus. So for this nucleus only, for identifying the nucleus only has been awarded with the Nobel Prize in the year 1908. So that is all we studied already. So yes, to do this experiment, he has taken a special particles called as anyone. What is the particles name called as? All of you.
Alpha particles.
Alpha particles.
So alpha particles means positive or negative charge. Is the
Positive charge.
Positive charge.
they are the helium 2 plus ions. So having sufficient energy to penetrate through the gold foil or whatever it is to some extent. So with that experiment, he has found a lot of observations and as well as he made so many conclusions. That is what we used to call as Rutherford model. So Rutherford atomic model. So now if you have noticed in Rutherford atomic model, he said like most of the atom having a empty space inside and positively charged nucleus only at present at very small in size and at the center it is located and the nucleus volume is very extremely small compared to the whole atom. And as we know, radius of nucleus and as well as radius of atom, how many times it is differs? All of you. So radius
10
of
power 5.
10 power 5 times smaller than radius of nucleus, radius of atom. So that is what we will say. If radius of atom is 1, then what is the radius of radius of nucleus is 1, then radius of atom will be how many times it is? 1
10
lakh.
power.
So 10 power 5, 1 lakh. That is the ratio of radius of nucleus and radius of atom. So that is what we studied in the last class. Now, in our today's class, we'll study the next most important concept and which we'll ask so many times. That is what it is, drawbacks of Rutherford's atomic model. So of course, Rutherford awarded with a Nobel Prize and a lot of things. But he is unable to explain something which is asked by like during the questioning and all. So that is what we will say, drawbacks of Rutherford. So this is the most important one. So please make it. So these drawbacks has been cleared by next model. So we all knows that what is the next model, everybody?
Bohr's
atomic model. Okay, so please keep reading. Rutherford's atomic model. Now, so before understanding his drawback, let us discuss something in our daily life. For example, let us imagine I will stand center of some circle. Now, you all people are running around me. Suppose you all imagine you are all the people are electrons. Now you are keep on running continuously. Now tell me, are you people are continuously going to run or after running certain time, you'll become energyless and you people will fall down. What will happen? If you keep on running in a circular path, so are you people are going to maintain your energy same or you are going to lose the energy and you will fall down? I want the response.
We will lose the energy.
So actually, these electrons are negatively charged and inside it is nucleus. Inside nucleus, what charge it is? Positive charge. So if these electrons are really revolving around the nucleus, so they have to lose that energy, because if they want to run, they have to radiate the energy, means they have to possess the energy continuously, so that when they are continuously revolving around the nucleus, so they will lose the energy and they must fall into the nucleus. But it is not happening in this electrons case. So Mr. Rutherford cannot explain the stability of the atom, because like how if the humans are revolving around particular thing, they will drain out, means their energy will lose and they will fall down. But in this coming to the electrons, it is not happening. So that is what stability. Even though electrons are continuously revolving, they are not losing their energy, and atoms are stable more. So they are not at all going to lose their energy. So this explanation why Mr. Rutherford unable to explain how the stability of electrons is maintaining or stability of atom, even though they are continuously revolving around the nucleus. So actually they should fall, yes or no? After revolving certain time, they must fall into the nucleus. Yes or no, guys? Because they lose the energy. Yes, please. But it is not happening. Why? Mr. Rutherford unable to explain. So that is the first disadvantage of Mr. Rutherford atomic model. So please write. Rutherford could not explain the stability of atom. That is the one major drawback. So what will happen here when electrons are, you can imagine, like for example, if the positive charge is present in the middle, so as we all knows that, so when you are keep on, suppose if I'll ask you to revolve, let me take one electron is present here. So negatively charged electron. So when I ask you to run you people around me, so you'll be keep on running, your energy will decrease, Finally, you must need to fall into the center. Is it right or wrong? All of you. So that is what will happen. So, but this is not taking place in the case of electrons. So Rutherford is unable to explain this. This is what, how energy losing, this diagram you can say how an energy losing electrons could fall into the nucleus. But is it taking place? Actually, it has to be done like this. Electrons should be fall into the nucleus after revolving. But it is not taking place. So why it is? So he is unable to explain. If it is takes place, this is how it will be happening. Concentric circles. Is it okay, everyone? With actually understand? Abrami? Yes, that is what. So Rutherford proposed that electrons revolve around the nucleus. That's fine. Under the influence of positive charge of the nucleus. So according to, if you have taken, but if people don't know, when charged particles revolve around the oppositely charged body, then they must lose the energy in the form of radiation. What do you mean by radiation? Anyone? What do you mean by radiation? You all heard this word in our daily life. Radiation. Radiation means in the form of what? Yes, please. What do you mean by radiation?
Heat, sir.
Heat. So, Mr. Rutherford said that electrons are revolving around whom hurry? Electrons are revolving around? Electrons are revolving around whom? Positive charge.
Nucleus.
Because by that time there is no discovery of neutrons. So Mr. Rutherford said that, what he said, you can read that, electrically neutrality means every atom contains what? Equal number of electrons and equal number of protons present in an atom. That is why atom is electrically neutral. And he said, revolution of electrons in the orbits, how they are not stationary. What he said, electrons are not stationary. What he said, Hari? You have written the point in the Rutherford atomic model. He said that electrons are revolving around the nucleus. Understanding? Electrons are not stationary, but they revolve around the nucleus in a specified path. That path only he called as, what is that path? Modern, modified one. The path we used to call as what, guys?
Orbits.
Understanding? So here he said that there is a static force in physics. We all knows that always the force is acting towards the center. What is that force called as? Whatever the electron you have taken. Yes, please.
Centripetal force, sir.
Centripetal force.
So he said that a centripetal force. So electrons are revolving around the nucleus with the influence of positive charge. Who is the influence there? Influence of positive charge from where, guys? Positive charge at the home. Who is positive charge? Nucleus. But if they are really influencing because of nucleus, actually electrons are what charge? Electrons are what charge?
Negative.
Negative charge.
Negative charge.
If they are revolving because of positive charge, then both are what charge? Same charge or opposite charge? Like charge or unlike charge?
Unlike charge.
Unlike charge. So unlike charge means they will show attraction or repulsion. They will
Attraction, sir.
attraction. So that they are continuously, they need to radiation. So they must around the oppositely charged bodies, then they will lose the energy in the form of radiation. What is that radiation means? That is what heat. So if you apply this theory to the Rutherford atomic model, then the fast moving particles, fast moving particles, that is what electrons, they must lose the energy continuously. So in their loss continuously, due to the decrease in energy, slowly, their speed will keep on decreasing or increasing. Energy losses, so that the speed will decrease or increases?
Decreases.
Keep on decreases, and they'll come closer to the nucleus. Ultimately, at certain time, they must fall into the nucleus. Yes or no? Yes, please.
Yes, sir.
Once the electrons will fall into the nucleus, finally, atom should be collapsed. Okay, so everything will be collapsed, atom. But is it true? Is it true?
No.
No.
No, sir.
Which is not true. So it is not true because we know that atom is a what? Atom is stable in nature. So that is why Mr. Rutherford failed to give the explanation for this. So that is the reason it's become a drawback. I hope everybody understood. Are you clear, Shruti? Understanding? So who will say this theory? Actually, as the electrons are revolving around the nucleus because of influence of positive charge. So as their opposite charge, they will lose their energy in the form of radiation. So this theory only will says that, what is the theory? They will lose the energy in the form of heat. That is called as Maxwell theory of electromagnetic wave. It is actually a physics. Maxwell theory of electromagnetic wave. So what it will says? Anyone can tell me? Maxwell theory of electromagnetic waves. What it will says? Oppositely charged particles, if they're influencing each, they will lose the energy in the form of what?
Radiation.
In the form of radiation. Akilan, understand, Akilan? Around, that is what we used to call as Maxwell theory of electromagnetic wave. Clear, Mr. Aswin, Sanjay? So this Maxwell theory of electromagnetic wave says that if the electrons are revolving around the nucleus because of influence of positive charge, they must lose the energy in the form of radiation, and slowly the speed should decrease. Finally, electrons must fall into where, guys?
Nucleus.
Nucleus. But so finally atom should collapse. But is it taking place? It is
No,
not
sir.
taking place. That is why it is the drawback of it. Have you all understand this one? Please let me know. Clear? Mr. Omar, Danishkar, Saronan?
Yes, sir.
That is what it is. First drawback. Second one, distribution of electrons in extranuclear portions. So, Mr. Rutherford said that electrons are revolving around the nucleus. in a particular orbits, but how they are revolving and how many their arrangement is not explained by Mr. Rutherford. That is why electron distribution we can say. We can use the word called as EC, electronic configuration. Do you remember that? You'll write 2, 8, you might be studied already. Yes or no? So Mr. Rutherford, he said that electrons are not stationary, but he is not given how the arrangement of electrons. That is what we will say distribution of two drawbacks. Distribution of electrons in extra nuclear portions. First point, anyone having doubt, please kindly let me know. Are you clear with the first point? What is the drawbacks of thing? You have to explain also in exam clearly. It's very, very important question. So distribution of electrons in extra nuclear portions. So right, Rutherford model of an atom, Rutherford model of atom was unable to explain the distribution of electrons in extra nuclear portion of atom. Are you clear? That is what electron distribution. So these are the two drawbacks of Rutherford atomic model. Is it okay, guys? Clear, everybody?
Yes, sir.
Yes. So if they'll ask you in exam, write the drawbacks of Rutherford atomic model. These 2 points you have to write very neatly. Clear, everyone? So anyone having doubt, you can ask me. So if you'll understand this, now with this one, Mr. New model has been proposed by Mr. Bohr's. That is what we will say, Bohr's atomic model. So please all of you keep reading Bohr's atomic model. And one more thing, before that you study alpha particles. Learn definition. So many times they will ask you alpha particles. Alpha particles. So we'll represent with this is a symbol. So it consists of what? 2 protons and 2 neutrons. So that is actually helium, electrons removed from the helium. Write it. It consists of 2 protons, 2 protons and 2 neutrons. So many times this definition they will ask you. Neutrons identical to helium nucleus. It can be represented as like this, guys, He2 plus, and atomic number is 2, mass number is 4. We will study this one in the coming classes. Okay, so this is what alpha particles. Please learn this definition. What is alpha particles? So totally it's 2 units of positive charge and 2 units of neutral charge. Totally it is 4 units. That is what you have to remember. So okay, everybody. Yes, please.
Yes, sir.
Right. Next kind of model. This is the last model. That is what we will say. Even presently, what we are using. That is what we used to call as Bohr's atomic model. Okay. So now This was proposed by a scientist name called as Niels Bohr in the year of 1913. Remember, so this is the model which has been proposed mainly to overcome the shortcomings of Rutherford model. Means the drawbacks of Rutherford model. So as Rutherford proposed, nucleus identified, empty space, electrons are revolving. This all the things has been proposed in Rutherford model. But Rutherford failed to explain two things. One thing, stability of the atom, and the second thing, what is the second thing? Just now I taught you. What is the second thing? Electron distribution. How the electrons are distributed out of nucleus, means surrounding by the nucleus. So to answer these two questions, with that only, he gave the concept of orbits, discrete states, or energy levels. So that is what Mr. Bohr's has been done. So to overcome this drawbacks of Rutherford model only, Mr. Bohr's has been, he gave the concept of orbits. That is why modern Rutherford model will study a word called as orbits, and as well as you will study a discrete states. I will say discrete states also we can call it as energy levels. So that is what it is. I will explain you what is that. Okay. So now let us discuss a few important things regarding Niels Bohr. So his full name is Niels Henrik David Bohr. Okay. So he's the one. He's also actually he's also a physicist and even a doctorate in physics. And his main contribution is clarification of the problems encountered in quantum physics. Actually, quantum physics is one of the toughest physics, which is like very, very tough. And he is one main contribution during that. And during even he has been made World War II. He's escaped to Sweden and spent around the last 2 years of the war in England and America. And he has even associated with atomic energy project. That is what nuclear bomb. Do you remember that? All of you during World War II. Yes, please.
Yes, sir.
Yeah. So even he is one of the work because during this World War II he has ran into the America and England, and there even he became associated with this the atomic energy project in America. And during 1916 he has been even appointed as the a professor of physics in American University, and finally for this. He has been answered all the drawbacks of Rutherford. That is why again, for his work on the structure of atom in the year of 1922, he has been awarded World's Best Civilian Award. What is that award? Everybody? That is what? Nobel Prize. So he has been awarded with the Nobel Prize in the year of 1922 for his further work on the structure of atom. That is what he has been cleared all the drawbacks of Rutherford, but of course, Bohr's model also having limitations. But he has been made its orbits and as well as energy levels, everything. So he has been proved. So that is why they have given Nobel Prize in 1922 for his work on the structure of atom. So this is what about Mr. Niels Bohr, and he is not a very old man. He has been died in just 1962. You might be studying. 1962 is not very far. Okay, so almost you can your grandparents' time, like Indira Gandhi time, you might be studying history. So that is what about him. So now let us comes to here. What is the postulates of Bohr's atomic model? So how he has been explained the drawbacks of Rutherford's. That is all we'll discuss it. So now if it comes to here, what is the postulates of Mr. Bohr's atomic model? So he has said that the electrons revolve around the nucleus in a closed circular path, which are called as, what we used to call, guys? Yes, please. Orbits, or we will say cells or we will say energy levels. So that is what Mr. Bohr's has been proposed. That is what the postulates of Bohr's atomic model. So right, keep heading, all of you. Postulates of postulates postulates of Bohr's atomic model. Omar, understanding Omar? Bohr's atomic model. First thing. So what he said? He said that electrons are revolve around the nucleus in a closed circular path. That path only we used to call as orbits, or we will say cells, or we will say energy levels. So please remember that. All of you right. First point. The electrons revolve around the nucleus in closed circular paths what we used to call them, guys? All of you, which are called them as orbits, or we will say cells, or energy levels. So please write it. That is the first postulates of Mr. Bohr's. Next, let us see that how I think you might be already have seen in our NCERT book also. So now you can see that is what Mr. Bohr's has been said. So he has been said this is what how the electrons are revolving around the nucleus in a particular orbits, particular closed circular paths. So that is what called as orbits, or we can say cells. Now, second thing, at the center, the protons and neutrons are present in the nucleus. Second point, the protons and neutrons. Of course, by the time neutrons have not been discovered, it has been discovered in 1920 only. Okay, but he has been proposed this model when 1913. But he has received Nobel Prize in 1922. So by the time in between that it has been happened. That is why we are studying the common thing. Okay. So the second point, the protons and neutrons are represented in the nucleus. The protons and neutrons are represented in the nucleus. Now you tell me entire mass of the atom depends on what? Only nucleus or including electrons also? From the beginning I am saying we will neglect the mass of electrons. Why, guys?
Yes.
Why will neglect the mass of electrons? Anybody?
It's very, very small. Sir.
Yes. Compared to how many times it is? One proton equals to how many electrons? One mass of one
1000.
how many times? Mass of one electron is equals to, we all knows that. Mass of one electron is equals to 1 by 1840 times less than mass of
Hydrogen.
mass of proton or hydrogen also you can take. That is what it is. So it's extremely small. That is the reason we people will neglect it. So second point, the protons and neutrons are present in the nucleus. So entire mass, who is responsible? Entire mass of the atoms. Yes, please. Who is responsible, guys? Nucleus, which are responsible for total mass of the atom. Okay. So now, who is responsible for positive charge of the nucleus? Everybody? Positive charge, who is responsible?
Protons.
Protons. That is the second point. Right. Now, third point. So, as we know, what is the first drawback of Rutherford? Anybody can tell me? First
He
drawback
could
of
not explain
Rutherford.
the of atom.
Yes. So, he could not explain the stability of atom because electrons are revolving, keep on. They need to radiate the energy. Means they will lose the energy in the form of radiation. So, they finally must fall into the where? They must fall into
Nuclear.
the nucleus.
Nucleus.
So, for that only, he said, Mr. Bohr said, each orbit is having a fixed amount of energy. So that is why orbits also we can call it as energy levels. So these electrons, they do not change their energy levels under normal conditions. That is why they will never radiate the energy, they will never lose their energy, and they'll never fall into the nucleus. So always the atoms are stable in nature. So that is what the third point, right? Each orbit has a fixed amount of energy. Each orbit has a fixed amount of energy levels under normal conditions. Sorry, energy. Therefore, orbits also we can call it as what? Orbits also called as energy levels. Therefore, orbits are also called energy levels. Okay, so at normal conditions, they are not going to lose their energy anymore. So that is what you have to remember. That is why electrons will never radiate the energy. So the electrons do not change their energy. Do not change their energy levels under normal conditions. Okay, so that is why they are stable in nature. That is why how the drawback of Rutherford has been explained by Mr. Bohr's. Next. So as we know that when energy is given, these electrons are promoted to higher energy levels and the source of energy is removed. So that electrons come back to their original state by releasing of energy. So that is what you can see. When they keep on revolving, that energy level in that orbit is not going to change. Suppose if you have taken, this is the nucleus and this is the first orbit. So this level, this cell having some energy. So that energy remains constant. So that electrons are keep on revolving in that particular thing. If I have taken next shell or next orbit, so this orbit is having some other amount of energy. So these electrons which are present in this orbit, they do not change their energy levels at normal conditions. So that is how the atoms are stable in nature. Is it okay, everybody? Yes, please. All of you?
Yes, sir.
Yeah. And these energies, if you have noticed it, they have been like energy levels is designed like 1, 2, 3, 4 or KLMN, like that we'll be designing. So you can notice in the book also. So you can see that how the structure. So they have been designed with N cell, M cell, L cell, K cell. So after the nucleus, the cell which is present, the second from the first cell from the nucleus, we used to call it as K cell, and the number is equals to 1. So next one is L cell, next one is M cell, next one is N cell. So till now, whatever the atoms are there, elements, more than K, L, M, N is not crossing. That is what, if you want, you can put K, L, M, N, O, P like that after that. but that is what it will be representing. Or we can represent with 1, 2, 3, 4. Like that also we can represent. So that is what is the fourth point. So all of you write it. So you have to draw the diagram also. My exam also, if they'll ask, you have to draw. The energy levels may be designated. The energy levels may be designated as 1, 2, 3, 4 or will represent with the K, L, M, N and O. That is what it is. Okay. So energy levels may be designated as 1, 2, 3, 4 or K11. Right. The energy levels which is nearest to the nucleus is highest or maximum. Anybody can tell me? Suppose if I have taken this is the nucleus, where the energy level is more, the shell which is at nucleus or the shell which is at far away from the nucleus. Anyone?
Far away.
Far away. That is what you have to remember. Very good, Noor. So if you have taken